Hello students, I am Reena. Welcome to Math Fam. This is surface area and volume of grade 10 topic here. So first let us discuss what have you learned here. What is the meaning of surface area? This is solids means it's nothing but 3D figures. So there will be three dimensions for any of the figures here. So surface area is sum of areas of all the faces of a solid will give you surface area, and then the unit is always going to be the square unit because you are calculating area here, whether it's a total surface area or curved surface area. Then there is a volume. Now what is the meaning of volume of any 3D figure here? Amount of space or the quantity a solid figure occupies or hold it called its volume, and the unit is always going to be cubic unit. Now in grade 9 you have learned all these figures, 8th and 9th grade. So first 3D figure is cuboid, that there are 6 faces, 1 2 3 4 5 6. Now all these faces are nothing but the two-dimensional figure. So if you see here, this is nothing but a rectangle. So what will be the area of this? LH, this will be BH, this one will be LH, and this is also BH, this will be LB, and this is also LB. Now if you will take the surface area, it will be sum of all these its faces area. So whenever we take lateral surface area, what is the meaning of lateral surface area? When you are talking about the four faces which is vertical, the surround to that excluding bottom and tops will be 2 times LH plus 2 times BH, and 2H is common, L plus B. Similarly, total surface area you are going to include top and bottom also, so it will be 2LB plus 2LH plus 2BH, and 2 is common, so you can take LB plus LH plus BH. And the volume of the cuboid is LB into H, right? Similarly, cube is nothing but all the sides, all the edges are equal here. So length, breadth, height, everything is, I have taken it as A. Now here, this is going to be A square area, because this face, if I take it as a square, A square, A square, A square. So if we take lateral surface area, it's going to be area of these four faces, so 4A square. If you take total surface area, you are going to here include the top and bottom also, this top and bottom also, that is going to be here 6A. Volume of a cube is A cube, right? And then cylinder, always remember the net, because surface area, it becomes very easy if you remember the net of 3D figures. Now this is a cylinder. Cylindrical face will have circular bottom, then circular top, and the one curved surface. This is your curved surface. How are you going to get it here? That curved surface, if you open, if you fold a rectangle, you get a cylinder, open cylinder. Now you know that here, why did I write down here L into B? Because if I need to find out area of this curved surface, I can take L into B, but there is no length here because it's a curved surface. So your length of this is going to be equals to this circumference, right? So that is why we take it as 2 pi r, and the height is h. So L into B is the area of this rectangle. That's why you get the curved surface area as 2 pi RH. Total surface area, because the top face is circle and the bottom face is also circle with radius r. So area of each circle is pi r square and pi r square. So here 2 pi RH is the curved surface area, and top and bottom circle will be 2 pi r square. So total is going to be 2 pi r is common, r plus h. Then what is the volume? We remember as area of base into height. So what is the base area here? It is going to be pi r square, and this height, then that is going to give you volume. So what is the volume of a cylinder? Pi r square h. Then there is a right cone. Now what are the dimensions here? This is called slant height. Then this is called height. This is radius. Now you can see that it's a right cone, right angle triangle. So we can use here Pythagoras theorem. L is the hypotenuse here. So L square equals to h square plus r square. And this is the net of the cone, right? We get a sector here. If here you get circle of radius r. About the CSA, there is a way to derive. It's a pi RL, and total surface area of the cone is curved surface plus area of circle. So this is going to be nothing but pi RL plus pi r square. Here pi RL plus pi r square, and pi r is common, and then you get r plus l. And what is the volume of the cone? It is always 1/3 of the cylinder volume. That 1/3 of pi r square h volume is going to be cone's volume, right? After that, the next figure is sphere. Now if you take sphere, if you put the thread around this sphere, and if you will see, it's going to fill four circle. So that is why we take total surface area as 4 pi r square, right? And the volume is 4 by 3 pi r cube. One more thing you should remember, whenever we take sphere total surface area or curved surface, it's going to be the same because there is only one surface here, right? Which is 4 pi r square. And next figure is hemisphere. Hemisphere is nothing but one. This is half of the sphere, so curved surface area will be 2 pi r square. But here if you put a lid here on top of hemisphere, this is also circular in shape. And what is the area here? Pi r square. So the curved surface area means the area of this curve is going to be here 2 pi r square, which is half of sphere. But if I take total surface area, it will become 3 pi r square, and the volume, because you are cutting sphere into half, it's going to be half of the sphere volume, which is 2 by 3 pi r cube. Now other than this, you should always remember here conversion unit also. 1 meter is always 100 centimeter. When we take 1 square meter, so we can do squaring both sides. Don't multiply by 100, it will be 100 square. So 1 square meter, which is the area, if you convert it into centimeter square, you have to multiply by 10,000. Similarly, 1 cubic means this is about volume. So I can do here cubing both sides to get cube. So 1 cubic meter is 100 cube, which is here it is nothing but here 1 million cubic centimeter, or it's going to be 10 lakh cubic centimeter. Other than that, you should always remember 1 centimeter is 10 millimeter, then 1 square centimeter is going to be 100 millimeter square, and then 1 cubic centimeter will be 10 cube, which is 1000 cubic millimeter, right? Millimeter cube. So this is the way to do the conversion. Other than that, in volume, you should remember here 1 cubic meter is always 1000 liter, and 1 liter is 1000 cubic centimeter. Because 1000 liter is 1 kiloliter, so 1 cubic meter can be 1 kiloliter also. You should remember all the formula, but you will see the combined solid. It will be combination of more than one 3D figure. So what do we do here? If I have to find out volume of any combined figure combination of solids, you will add the volume of each solid to get the total volume. Now here if you'll see, it's written cylinder is surmounted by a hemisphere. So this is a cylinder. To get the volume, I'll take occupied space by cylinder plus occupied space by hemisphere. So what will be the total volume? Volume of cylinder plus volume of hemisphere. Always first put the formula because radius is same. So pi r square h plus 2 by 3 pi r cube. You can take pi r square common, then the first term will be left with h, and the second term will have 2 by 3 r. Right? Why do we always, before substituting the value, you take whatever is possible to take common, so your calculation becomes easier. Now the next one here, how to find out the volume of a hemisphere surmounted by a cone. So you will take the volume of the hemisphere plus volume of the cone. What is the volume of a hemisphere? Now this is only the formula, 2 by 3 pi r cube, 1 by 3 pi r square h, right? And 1 by 3 pi r square is common because here radius of hemisphere and cone are same, so you will be left with 2r plus h. Similarly here, but the surface area you need to be more careful because total surface area of any combined solid is the sum of surface area of visible surface. Now here if you will see, this is again cylinder surmounted by a hemisphere. If you will see what is the visible here surface, curved surface area of cylinder, then bottom of the cylinder, and curved surface area of hemisphere. So you can remember like that, whichever place you can paint, right? Or you can stick the paper. That surface is called surface area of any combined solid. Now if you will see here, base of the hemisphere and top of the cylinder is inside the figure. It's not visible because it's joined together. So you are not going to consider this part. You will take only here the outer visible surface area. So what will be the TSA of this figure? CSA of hemisphere, then CSA. See, this is CSA of hemisphere, this is CSA of cylinder, and the base area, which is base of cylinder, which is pi r square because it's a circle. So how are you going to take it here? 2 pi r square is the curved surface area of hemisphere. 2 pi rh is the curved surface area CSA of a cylinder. Pi r square is the area of the base. Then total here you can add this 3 pi r square plus 2 pi rh. Again pi r, take it common, 3r plus 2h to do the calculation, right? Now again here hemispheres are mounted by a cone. If you will see again what is the surface area is visible here, you will take CSA of a cone and CSA of hemisphere. You will not take the top of the hemisphere and bottom. This part is inside, it's not visible. So you will not include the top of the total surface area of hemisphere. So it is just CSA of cone and CSA of hemisphere. CSA of cone is pi rl plus 2 pi r square. Pi r is common, l plus 2r, and then you will substitute the values of these dimension to get it. Now here this is one example. This is a very common example you get it, whether it is surmounted by a hemisphere or this is the cube where there is a hemispherical depression. You are removing hemisphere from the top of the cube. Now here if you will see this cube, the edge of the cube is 7 centimeter and your hemisphere diameter is also 7 centimeter, right, which is the maximum possible diameter when you are cutting the hemisphere. So it is, radius is going to be 7 by 2, which is half. How will you get the surface area? You know that you know TSA of a cube, but this circular part is removed from the total surface area of a cube. So I am doing here total surface area of a cube is 6a square. Then you have to remove pi r square because this top won't be visible. It is removed. It's a depression, right? But in the depression, this extra area is included, which is the CSA of the hemisphere. And what is the CSA of a hemisphere? Curved surface area of a hemisphere 2 pi r square. So if you simplify here, it will be 6a square plus pi r square. So you, in these combined figure, you need to see which area is visible, surface area is visible. Based on that, you are going to consider the area. You'll add or subtract the area. Now, how will you get the volume? Because you can take volume of cube and you have removed this part. So it's going to be, you need to subtract volume of hemisphere. So volume of cube is a cube and volume of hemisphere is 2 by 3 r cube. So this is the way, these are the all formulas. So read it, you use the basic formula to find out whether what is the surface area and volume of the combined figure. Thank you for watching this video. Please like, share and subscribe. Also keep practicing.